Good afternoon, teachers. My name is Steve. I'm here to talk a little bit about weather. We're going to be talking a little bit about each of the clarifying objectives as we look at some of our reteaching as we do, gathering data from our previous teaching times, as well as what we're doing here in the spring as we're gathering things to talk about our standards to help our students to better understand the atmospheric conditions that we have in 5th grade weather. Our first objective that we're going to talk about is understand weather patterns and phenomena making connections to the weather in a particular place and a particular time. That's our definition of weather, in a specific location and a specific time. Our first clarifying objective, our verb is to compare. We need to compare daily and seasonal weather changes, including wind speed, wind direction, precipitation, and temperature, as well as some of our seasonal patterns. We're going to talk about knowing that weather can change from day to day, and many factors are used to measure to describe that weather. Using wind speed, wind direction, precipitation, temperature, and air pressure. Students know that different latitudes and hemispheres, and those will bring different weather as well as different seasonal patterns. So with that one, we should have gathered data from the summer, our first week of school. We should have gathered data from the fall. As we start talking about weather in December, we're still in fall, and we lead into winter as we're starting off there. We're gathering some data from that one. Now we're looking at the spring season. What kind of data are we getting? How are our temperatures changing? What other things are we seeing with our weather? Using this, we can use our weather station data. For example, Petrie has the WeatherLink software, which brings up their data that they have. This is current data from 3 minutes ago. It was posted. 60 degrees is our temperature right now. How is that different than yesterday? Yesterday was 75 degrees. It was a clear sky. It was a beautiful day. Today, we're at 60 degrees, 10 degrees colder. Why is that? We're having a barometer that is 30 and 200ths. It says that pressure is falling slowly. Why is that? What is that changing for us? What was our pressure yesterday? Our pressure was higher. This number yesterday was 30 and 1200, so it was a full tenth higher. Not a big difference as we look at numbers, but with pressure changing, that's important for us. We have our wind direction at southeast, and it's coming at 6 miles an hour. This tells me that I had a gust of 14 miles an hour recently. So we have that information as well. Coming from the southeast, why is that important for what we have right now? We know that our weather travels from the west to the east. So I'm going to pull up this windy map. This is a map that's on Haiku that you can pull up and has lots of different features for us to look at for as we're predicting as well as showing information. So this one has our winds. I have it set for, let's change it to winds. Excuse me. Okay, so these are our winds that are swirling on here and have our temperatures as well. So we can see our winds are swirling in from here. We have an interesting thing with this because what I see with this is this swirl. We have high pressure that is off of Pennsylvania, New York, New Jersey, but that high pressure causes my winds to travel in a clockwise fashion, where a low pressure sends them in a counterclockwise fashion. So if we look at that one here, I've got my winds flowing here in this direction. That's where my low is, and my high is up here, causing those winds to circle in here. Okay? So if I'm comparing my daily and seasonal, I'm using my qualitative, my quantitative data. My observations, what the maps are showing me, I'm looking at things that are changing because of that one. With my winds coming in from the southeast, it's blowing in some decently warm air. If my wind directions change to the northeast, all of a sudden now I've got colder air that's blowing down from up there. It's coming from the northwest. For example, if I have my winds coming from the northwest, it's blowing from that direction, so it's blowing here. It's blowing down this area. What do I see here? I see some rain, I see some snow, and that cold air will be coming down to us. And that leads into our conversation of why does latitude matter? The further we are away from the equator, the further we are from the tropical regions, getting closer to the polar regions. It causes us to go from warm to cold. So the further we are away from the equator, the colder we're going to get. Who wants to go and live in northern Michigan? Who wants to live in Florida? Why is that one? People want to live down here so they have the warmer weather in the wintertime. They don't want to be up here for that cold, frigid winters. We have that going on here as we talk about latitude. So as we're looking at our comparing with our first objective, just looking at those things, understanding that the opposite seasonal patterns, we know that the opposite seasons, we get something that is down deep into the south in the southern hemisphere, is going to have opposite weather patterns. So with that being in mind, we know that one. Our weather data, from our second quarter benchmark shows that kids understand that. You've taught that one well. But the part with latitude and being further away from the equator, that part there's some iffiness with some students on that one. So look at those things for that one. Okay? Utilizing the data and the information that you have to be able to explain what's happening from day to day and within seasons.